Hi everyone. This is the first video in organic chemistry. So we'll be using this part 2 of your study guide. And this first part is all about naming. It's really important to be able to change between the name and the structural formula. And so you'll see what that looks like. Writing something out like this is the structural formula. It's condensed, making it small as possible. Just to distinguish that from other kinds of formula, there's another one called the molecular formula, and that's a bit simpler. That just gives the total number of atoms in the whole thing. And so that's not quite as useful because this could be put together in a lot of different ways. So that's why we will be using the structural formula throughout, and I'd like you to do that too. So this first part is naming, and it's really important to be able to use a name, but also understand the name. So as we learn new functional groups each time, we will be learning how to name them. And so today we're just going to look at the most simple kind of structure, alkanes and alkenes and haloalkanes, and I'll show you the basis of naming. So this page in your study guide gives you some really basic steps to go through. So the first thing to notice is the functional group. Today we won't have any special functional, well, I guess we won't alkene, but we won't have very complicated functional groups, but we'll keep adding those on. We will identify the longest chain. I'll show you what that looks like. Each carbon in the chain, the longest chain, gets a number when we'll need to use that in the name. And then there will be side groups that we will have to name. So I think the best way is to give you some examples. Oh, and just to mention, this page here gives you examples of all the functional groups we're going to learn this year. Although today we'll just be seeing these ones, alkanes, alkenes, and haloalkanes. And this is one of the side groups, alkyl. And so they're lowest priority. And although alkenes are slightly higher priority than alkanes, and I'll show you what that means. So this will be a good reference throughout the whole year. And also to point out that you'll be trying to remember these. Keep these in mind. These tell you how many carbons. Meth is 1, eth is 2, prop is 3, etc. Okay, so for these first two examples, I haven't really mentioned the functional group here because there really isn't one. They're just alkanes. And alkane is just a carbon-carbon single bond, a normal single bond. And so that's the same everywhere. So what we do always then have to look for is the longest chain. And so that is continuous carbon, 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 carbon bonds. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons long. Don't worry if sometimes we draw the bond and sometimes we don't, that's the same. So if it's 9 carbons long, then that's going to be non-ane. And the ANE is for the alkane, because that's the kind of functional group, carbon-carbon single bond. And then we need to number it so that the side groups get the lowest possible number. Okay, so the top here, starting from the left to right, then the side groups would be numbered 4 and 6. The bottom, from right to left, they'd also be numbered 4 to 6, so they're actually the same. There's a rule for that as well. Then we put them in alphabetical order. So the two side groups here are methyl with a YL, and that's 1 carbon, and 2 carbons, ethyl. E comes before M, A, B, C, D, E, F, G, so alphabetically. So it will get the lower number because they're the same. We'll see in this one they won't be the same. So, and we need to write those numbers in the name. So finally, the final name is 4-ethyl 6-methyl nonane. So we've got where is the ethyl, where is the methyl, and how many carbons long is the main chain. And E comes before M because alphabetical. That is the main idea. You'll be using this again and again and again. So there's just one more example here, just a little bit more complicated, just to do one together before you try some difficult ones on your own. So we're looking for the longest continuous chain, and that might not be straight. It doesn't have to be straight, it just has to be together. So there we've got 8 carbons. That's also 8 carbons. But if I do one this way, so if you can see, going in a U, that's not 8 carbons, that's only 6 carbons. 7 carbons, sorry. So there are actually 2 ways of making 8 carbons, and there's a rule for that. There's always a rule. The yellow one has the side groups are more simple. So if we make the yellow one, there are more side groups, but each side group is very simple. If we did it the other way, we would have had this weird L-shaped side group, which is quite difficult. So it's not just to make our lives easy, but it is the rule. We must make it as simple as possible. But we've got our main chain, our longest chain is octane. Then we need to number them. So if we go from left to right, then the side groups are on 3, 4, 4, 5, 5. If we go from right to left, then the side groups are on 4, 4, 5, 5, 6. So they're both 4, 4, 5, 5, but one is 3 and one is 6. So we must number them with the lowest number. So this time they were different. And now I'll name the side groups. So here we've got a methyl, 2 ethyls on the bottom, another ethyl on the top, and then this one here with 3 carbons, propyl. And so we have 3 ethyls and this time. And how do we say there's 3? Do we have to say ethyl, ethyl, ethyl? No, we don't. We can use tri. So all of these, all of this information is listed here on this first page. When there's more than one, then di or tri or tetra or penta are used to say how many there are. And then they're put in alphabetical order. So ethyl is first, methyl is next, remembering the alphabet, and propyl is third of these 3. And it doesn't matter about the tri. Don't use the T for the alphabet, use the E. So try to notice the punctuation here as well. Between numbers is a comma, and between a number and a letter is a hyphen or a dash. And so that's the final name. So the name gives us the perfect exact structure. And so we can see that name and know exactly what the structure is going to look like. And if we know the structure, then we can make exactly that name. And everybody can understand that no matter who's reading it. This is a standard IUPAC naming system. And that if you can do that, then we'll add little bits on, but this is the basis of it, and that was quite a difficult one. So I just want to mention a couple other things that you will see. One is sometimes things can go in a circle instead of a line. So this is going in a circle. It's 4 carbons, so it's bute. They're all single bonds, so it's ANE. But how do we say that it goes in a circle instead of stopping at the ends? We say cyclobutane, just like that. And I mentioned single bond. Well, what about when something has a double bond? Then it's called an alkene. Now it has a functional group, so this is something different, something special. It must have the lowest number possible. So if we number from left to right, then it's on 2. If we number from right to left, then it's on 4. 2 is smaller than 4, so we have to use left to right. 6 carbons, so hex, and it's ENE this time instead of ANE to show that it's an alkene. So this is how we name the difference. Watch your spelling, read carefully. And there's a side group here, so 5-methyl hex-2-ene, sorry. And the two can go in different places. Both of those are totally fine. You'll see later some advantages to putting it in the middle. Sometimes that's a bit easier, but for this one it's not. Finally, there are haloalkanes. The halo comes from halogen. Halogens are group 17, fluorine, chlorine, bromine, and iodine. These are quite common in organic chemistry, carbon chemistry. So let's look at a slightly complicated example, but you'll get to see lots of things in there. Okay, so here's something with lots of different halogens all over it. I'm not sure how common this would be in real life, but we start the same way. 3 carbons is the longest continuous chain of carbons, and they get numbers so that the side groups, which are halogens, have the lowest numbers possible. So we're going to start at the right because that will be 1, 1, 2, 3 for the side groups. These halogens are named a prefix, like methyl is prefix at the beginning. These are also at the beginning. All right, so there are 2 bromos, dibromo, and there is 1 chloro. So these are alphabetical order, B, C, F. 1, 1, dibromo, 3 chloro, 2 fluoro. So it's not 1, 2, 3, it's by the alphabet. And propane, because it's just an alkane, all single bonds. So those are some basic examples. I hope that's helpful, and bring all your questions and we can do some practice together. There's lots of practice in your study guide. We'll do some of these together when I see you. Bye-bye.